Greetings. Sorry I missed you for a couple days last week. We're going to make up for a little lost time by doing a video lecture. So we're going to talk about the intermediate value theorem, and if you'll recall, it says this, that if two things happen, then something else happens. So it says that if f is continuous on this closed interval a to b, first, and second, capital N is a number between f of a and f of b, then if those two things happen, then the intermediate value theorem assures us that we get this conclusion. There is a number c between a and b such that f of c is equal to n. And so I just want to remind you of what this visually looks like, because this sounds kind of complicated, but visually this is a very simple phenomenon going on here. So let's look at this picture. So let's start drawing this. A and B are x values, really important in this class, throughout the class, to keep distinct x versus y values. So A and B are x values. We'll put them on the x-axis, A and B. Of course, those x values will have y values associated with them by the function, namely f of a and f of b. So we'll put those y values on the y-axis. Let's say f of a happens to be up here, and f of b happens to be down there. Okay. Then we've got 2 points. One point with x-coordinate a and y-coordinate f of a, and the other point b, f of b, right about there. Okay. What else do we need to put in here? We need this number capital N that's between f of a and f of b, so it's between these two y values, so we're going to think of it as a y value. So we'll put that in here, somewhere between f of a and f of b, and we'll put a dotted line, dotted horizontal line, going through that capital N on the y-axis there. And then the conclusion says very simply that when we draw this continuous function that connects its starting point here with its ending point here, that because it's continuous, we cannot have any jumps or holes or breaks or anything. And so somewhere we have to cross this line that's between f of a and f of b. That's what the conclusion says, that somewhere we've got to cross that line. And that happens at an x value c, right, about here in this picture, that's between a and b. Now, of course, c can't be right on a because the function's clearly not crossing here, and it can't be right on b because the function's clearly not crossing there. All right? So it's really between a and b. All right, so that's the basic kind of picture. I wanted to say a couple things about how this conclusion is phrased. In particular, I've got this phrase underlined in purple and this phrase underlined in orange that I want to talk a little bit more about. And basically, each one of those can be rephrased. Okay. And so the one in purple just says C is between A and B. And another way that can be said is C is in this open interval a to b. All right, that says exactly that C is between a and b. And again, in the picture, that just says that C is somewhere between a and b, but not equal to either one. Right? That's why we got parentheses instead of brackets. Okay. So that's the rephrasing of the purple statement. Now, interestingly, the rephrasing of the orange statement is like this. Another way of saying that f of c is equal to n is saying that c is a solution to the equation f of x is equal to n. Right? That's another way of saying that f of c is equal to n. And this will be helpful because a lot of times problems will be phrased to include one of these, if not both of these kinds of statements, right? So C is a solution to the equation f of x equal n, because all that means is solution to the equation means when you replace x with it, you get a true statement, and that's this statement here in the conclusion. Right? So those are rephrasings of part of the conclusion of the intermediate value theorem.